Hello guys, in this video we are going to learn about matrices, in the sense how we are going to find the eigenvalues and eigenvectors. To begin with, we are going to find the eigenvalues and eigenvectors for a 2 by 2 matrix and then to a 3 by 3 matrix. As you know, the matrices are widely useful in the engineering. It is used in the finite element methods, that is in civil and structural engineering, and in network analysis in the field of electrical and electronics engineering. See, for a 2 by 2 matrix, as you know, there are 2 rows and 2 columns, and it is basically a square matrix. And we'll be having 2 eigenvalues. The eigenvalues are called the latent roots, proper values, as well as eigenvalues. And to find the eigenvalues, first we have to find the characteristic equation. The characteristic equation is given by determinant of A minus lambda I equal to 0. So that is nothing but determinant. You know the matrix A. So that is 4 minus lambda 1, 3, 2 minus lambda equal to 0. So you know that this is actually the matrix A, that is 4, 1, 3, 2 minus lambda I, that you know that I is a unit, I2, it's a unit matrix of order 2. So you'll get it as lambda 0, 0 lambda, and for that we are taking the determinant. So that's given by this. And so expand this determinant. You know that how to expand a determinant. It is 4 minus lambda into 2 minus lambda minus 3 equal to 0. So when you expand this, you will get 8 minus 2 lambda minus 4 lambda plus lambda squared minus 3 equal to 0. And this is lambda squared minus 6 lambda plus 5 equal to 0. So you have to factorize this. That is, you have to solve this quadratic equation. So you can use any method which is convenient to you. So when you add, you have to get minus 6, and when you multiply, you have to get 5. So the only possibility for us is minus 5 lambda and lambda plus 5 equal to 0. For these two, lambda can be taken as the common term. So lambda minus 5. And for simplification purpose, write the same lambda minus 5 here. So it will be easy for you to follow. So what I have to put 1. So this implies lambda minus 1 into lambda minus 5 equal to 0. Therefore, we conclude that the eigenvalues are lambda minus 1 equal to 0 will give you lambda equal to 1, and lambda minus 5 equal to 0 will give you lambda equal to 5. So these two are the eigenvalues, and they are called latent values as well as proper values. To find the eigenvector corresponding to these two eigenvalues, so the eigenvector is given by the following steps. So how to find the eigenvectors? You have to proceed like this. That is that is A minus lambda I of x is equal to 0. So what's that meaning? You have the matrix A of 4, 1, 3, 2. With that matrix, you have to take that lambda in the sense, you know that I is I2 unit matrix, so 0 lambda. And with these matrices, we are multiplying x1, x2. Okay. So simple way is, for the diagonal elements of the matrix A, simply you put lambda. So you will get 4 minus lambda 1, 3, 2 minus lambda, okay, into x1, x2 equal to 0. So now when for the first case, let us take the case 1. In the case 1, we are taking the first eigenvalue, that's lambda equal to 1. So your A minus lambda I of x will be 4 minus 1, that is 4, that is I'm taking lambda as 1, 1, 3, 2 minus 1 into x1, x2 equal to 0. So what you'll get here, this is 3 and this is 1, 3, 1, x1, x2, okay, equal to 0. All right. So this implies, let's write. So now this is equal to 0. Let me write. This implies, okay. So this is 3x1 plus x2 equal to 0. Both the equations are same. So from this I can get 3x1 is equal to minus x2. and x1 is equal to minus x2 by 3. Okay. So your x1, so suppose if I see, let us take x2 as some k, some constant, then this implies x1 is equal to minus 1 by 3 of k. Okay. So in continuation, say in this I got x1 as minus 1 by 3 of k. Let us choose k as 3. See, I can take any value for k, but the thing is the least value is always the best. So you will get x1 as minus 1 by 3 of 3. So you will get it as minus 1. So what I can write the vector capital X as x is x1, x2. So what is x1? x1 is minus 1. And what is my x2? x2 is nothing but k, and that k I have taken it as 3. So I'll get it as 3. So the first eigenvector is x is equal to minus 1 comma 3. See, now in the next one, let's take the case 2. What's our case 2? Our lambda is nothing but equal to 5. Okay. So our A minus lambda I of x is equal to 0 implies your matrix A. What's our matrix A? Let's go back to our matrix. So it is 4 minus 5, and you have a 1, then 3, 2 minus 5, that into x1, x2 equal to 0. Now you will get 4 minus 5, that's minus x1, and plus x2 equal to 0. Now this is 3x1, and this one, my 2 minus 5 will give you minus 3, x2 equal to 0. See, both these equations are similar or same. So you can write x1 equal to x2. That is minus x1 is equal to minus x2. So you'll get x1 is equal to x2. And similarly from this equation, you will get 3x1 is equal to 3x2, and therefore x1 equal to x2. So both of them gives the same answer. So which implies that x1 equal to x2. So if I take x1 as 1, then x2 is also 1. If I take this as 2, like this. So I can write the other vector as 1 and 1. So for convenience purpose, for the first eigenvalue, let us take the eigenvector as x1, and for the second eigenvalue lambda equal to 5, let us take the eigenvector as x2, so which is 1 comma 1. Therefore, you can conclude that the eigenvectors are minus 1, 3 and 1 comma 1. That's it. So keeping this in mind, we can extend this to any 3 by 3 matrices. And for right now, let's stop with this. And in my next video, I'll tell you how to find the values for a 3 by 3 matrix. Thank you.